rise. We are the power leader for subject chemistry. We are from Group 4. I'm Boshuang.
And CHEE.
I'm DHARSHINI.
And I'm NING. Today we will learn about Chapter 2 Thermochemistry, and so please enjoy our next 15 minutes of our teaching sessions.
Chapter reminder, Chapter 2 has the highest allocation mark in PhD 2.
So let's start now.
So first of all, I will briefly explain about some definition for some important enthalpy change. So for the first one is enthalpy of formation. For enthalpy of formation, it means that the heat change when one mole of a substance is formed from its most stable state at the standard condition, which are 1 atm and 298 Kelvin. And reminder, for the compound form, it must be one mole only. If it is more than 1 or less than 1, then it is not considered as the standard enthalpy of formation. Some element in its most stable state will have zero standard enthalpy of formation. For example, there are chlorine gas, hydrogen gas, oxygen gas, and graphite. These compounds are all compounds with zero standard enthalpy of formation. Secondly, I will be talking about enthalpy of combustion. Enthalpy of combustion is the heat release when one mole of a compound is completely combusted in oxygen gas. It is an exothermic reaction, so the sign for this enthalpy of combustion is always negative. Thirdly is about the enthalpy of atomization. Enthalpy of atomization means the heat absorbed when one mole of gaseous atom is formed from its element. So the gaseous atom can be formed from solid to gas atom or from gas atom to another gas atom. It is an endothermic reaction, so the sign for this enthalpy will always be positive. Next will be the enthalpy of neutralization. Enthalpy of neutralization means the heat release when one mole of water is formed when acid reacts with base. This enthalpy of neutralization is similar with enthalpy of formation and enthalpy of combustion. They are all exothermic reactions, so their sign will always be negative. Other than that, enthalpy of hydration means that heat release when one mole of gaseous ion is hydrated in the aqueous solution. Lastly, it will be the enthalpy of solution. Enthalpy of solution is the heat change when one mole of substance is diluted in aqueous solution to form an infinite dilute solution. Now that we are done with all the enthalpy changes, let's move on to the Bondhaver cycle. But before that, let me introduce you some terms for you to understand better before we going deep into the Bondhaver cycle. So other than the enthalpies that we learned just now, we also need to learn about some terms before we learn about Bondhaver cycle. And for the first one, it will be lattice energy. Lattice energy is available for two situations. So for the first one, solid ionic compound will be formed from its gaseous ion. However, for the second situation, the gaseous ion will be formed from the solid ionic compound. However, in the Bondhaver cycle, we usually apply the first situation in which the solid ionic compound is formed from its gaseous ion. And the next one, electron affinity, it is the energy release when gaseous atom receive one mole of electron to form an anion. And lastly, for ionization energy, it is the minimum energy required to remove one mole of electron from one mole of gaseous atom. So let's recap. There are 6 types of enthalpies, which are enthalpy of atomization, formation, neutralization, hydration, solution, and combustion. And there are 3 terms for everyone to remember about Bondhaver cycle, which are ionization energy, electron affinity, and the lattice energy. So next, NING and DHARSHINI will take over the floor and further explain about the Bondhaver cycle.
Okay, now for this, we will look at these examples. So for A, we will have to construct a Bondhaver cycle for lithium chloride. And B, we have to calculate the lattice energy of lithium chloride. So the data given is like here. So we will try to analyze the question first before we try to do the questions. So for the first data given, this is about enthalpy of formation of lithium chloride. So we will have lithium chloride and it is in solid state. And for we want to form this lithium chloride, we have to combine lithium and also fluoride. And lithium in its stable state will be solid. And fluoride, its stable state will be in gaseous state. So now, gaseous state we have to remember, we have to add 2 at here, which represent these 2 atoms. So now we have 2 atoms here, but the final product we only want to have 1 fluoride. So we have to add 1/2. So 1/2 multiplied with 2, we will get 1. So for the next one, enthalpy of atomization of lithium. Lithium, and it's given as solid state. So enthalpy of atomization is mean that the final product that we get will be in gaseous state. So it will be like this. And the third one, enthalpy of atomization of fluorine gases. Fluorine gases. And after it undergo atomization, it will get fluorine gas. And now the same things. We have 2 atoms of fluorine gases, so we have to add 1/2 here. So the final product that we get will be 1. And the next one will be first ionization energy of lithium. Lithium, and it's in gaseous state. So when we undergo ionization energy, we will remove 1 electron. So after remove 1 electron, lithium will be in positive, which means lithium carbon cation. So it will be still in the gaseous state, but now we have to plus with 1 electron here, because we have been removed this. So for the second last, we will have the electron affinity of fluorine. Fluorine, and it's in gaseous state. Electron affinity means that we are going to add 1 electron inside. So after addition of 1 electron, we will get fluorine anion. So from fluorine anion, we will have gaseous state. Because before that, we will be gaseous state. So after that, we will be still the same. And the last one will be lattice energies of lithium fluoride. Lithium fluoride. So lattice energy means that it is a formation of solid ionic compound. So it is in solid state. And it will be formed from lithium with a plus, which means lithium carbon cation in gaseous state, and also fluorine, which is fluorine anion in the gaseous state. So we will get our final product, lithium fluoride.
Okay, now let us try to draw the empty cycle diagram of Bondhaver cycle. So there are a few tips and steps that you can follow to draw this. So first of all, let's look at the Bondhaver cycle. It starts with enthalpy of formation and ends with lattice energy. And then the second step that you can follow is use FAA, IE, EAL cycle. F refers to enthalpy of formation, A refers to enthalpy of atomization of metal, another A refers to enthalpy of atomization of non-metal, and then IE refers to ionization energy, EA refers to electron affinity, and then L refers to lattice energy. So for your information, the cycle can be different for different questions where they will try to give you 2 ionization energies or 2 electron affinities. Okay, so let's look into the steps. So the first step is write thermochemical equation for all the enthalpies, and the second step is arrange all the equations according to the FAA, IE, EAL cycle and label it. So, and the third steps is target equation, where the target equation is enthalpy of formation. So, as you know, in Bondhaver cycle we have target equation
and the target equation is enthalpy of formation. It must be on the top of the Bondhaver cycle. And then the last step would be the construct the Bondhaver cycle. Okay, so now let's take a look at the Bondhaver cycle. As I mentioned earlier, we can use FAAIEEAL cycle. So as you know, the F refers to the enthalpy of formation, and the enthalpy of formation is the target equation which must be on the Bondhaver cycle. So this is the equation, and we also know that enthalpy of formation is the enthalpy of overall equals to -617 kJ per mole. And then the second one is A. It refers to enthalpy of atomization of metal from lithium to gaseous atom of lithium, and the value is positive 161 kJ per mole. And then the third one is enthalpy of atomization for non-metal from fluorine gas to 1 mole of gaseous atom of fluorine. And then the third one is IE, which refers to lithium gases to cation of lithium. And then the value is positive 520 kJ per mole. And then the fifth one is EA, Electron Affinity, for fluorine, which will form an anion, and the value is -328 kJ per mole. And then the last one is lattice energy, which NING will help us to find the value of lattice energy.
So we have drawn the Bondhaver cycle here. Now we will have to answer the part B, which is calculate the lattice energies. So for enthalpy of formation is actually a combination of H1 until H5. So now enthalpy of formations, and we get the value. It is -660. So for enthalpy of formation is actually -670 kilojoule. So we write it at here. And for the H1 is here, and it is positive 161 kilojoule, plus with the second one 79.5, and the third one 520, and the fourth is negative. So we have to write negative, don't forget it. And the last one will be the lattice energy. So we get all these values, so now we can calculate the lattice energy, which is also same as H5. And the answer for this is negative 1049.5 kilojoule. And the most important thing is that we have to write per mole, because for lattice energy is actually the formation of solid ionic compounds in 1 mole. So the answer for this unit is kilojoule per mole.
Okay, now for my turn, I will explain another way that represent the Bondhaver cycle, which is energy level diagram. So before I start to teach how to draw the energy level diagram, there are some basic things that we need to know. So firstly, when the enthalpy change is positive, so the error should be go up. And on the contrast, when the enthalpy change is negative, so the error should be go down. Secondly, the y-axis in the energy level diagram is enthalpy. So when the y equal to 0, it means that the enthalpy change equal to 0. There are only elements in the standard state will exist only. So moreover, we need to check that is it all the equation balanced in energy level diagram. So besides, we need to write down all the phases beside the element within the equation. And last, we need to label all the enthalpy change besides the error. And one error only represents one enthalpy change only. So we when we doing the energy level again, we need to do it one by one. Okay. When we drawing the energy level again, we always start with the reactant, which are the elements in standard state. So first, we will start with the atomization of lithium, followed with the atomization of fluorine gas, and then will be the ionization of lithium, followed with the electron affinity of fluorine in gaseous state, and the last will be the lattice energy become the lithium fluoride, which is the final product. So we also can choose the elements in standard state to become the final product through the formation, enthalpy of formation. So refer to the Hess law. So we can state that no matter the reaction occur with one state or more than one state, the enthalpy change will always be the same. So from the energy level again, we can know that there are two pathways we can form the final product. One through the formation, one through this move up and then move down through the lattice energy. So from there we can construct the equation like this. So we just substitute the enthalpy change given by the questions, so we can find out the lattice energy. So that's all for the energy level again.
Thank you for watching.